Good day, students. In this script, we're going to be going over differential equations. I took a look at the 2006 to 2013 free response questions, and I consolidated them in the context of one problem. And we're going to be reviewing the different questions that can be asked for differential equations, all right? So we're going to be going over how to find particular solutions of a differential equation with an initial condition, how to generate slope fields, how to write down the equation of the tangent line or find the linearization of a function at a point, and how to use that to estimate, and also the concavity. Okay. If I do not finish all the problems in this first clip, do subscribe so you can get updates to the subsequent clips. Alright, so now let's take a look at the question. So it says, consider the differential equation dy dx equals y plus 1 over x squared, where x is not equal to 0. Let y equals f of x with f of 1 equals 2. Part A. On the axis provided, sketch a slope field. So we're going to sketch our slope field here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 points. We're going to draw the tangent line for 9 points. Tangent line to the equation that has this differential equation right here. You notice that this x-axis, the y-axis has no points on them. Well, that makes sense because we know that x cannot be 0. If x were 0, in this differential equation, we're going to have an undefined slope. So that's why these points along the y-axis were excluded from our graphing points, okay? So what we're going to do is basically make a table of values here and go ahead and graph our um, tangent lines. So let's make our table of value. So I'm going to have my x, my y, and then the computation of my slopes. So the way I like to do it, I like to do it in order. All right, so I have my two table of values. So I'm going to use the x and the y coordinates to find out what the value of y plus 1 over x squared is, which is basically dy dx. That's indicated in the problem above, all right? dy dx is y plus 1 over x squared. All right, so let me set up my table of values right here. So y plus 1 over x squared is equal to dy dx. Okay, so I like to do it in rows. So we're going to do columns. I'm going to do the first column first, where x is negative 2. So for that one, we have negative 2, negative 2, negative 2. And then when x is negative 2 here, what is the value of y? It goes from 2 to 1 to 0. Okay? And then for the next column, we have negative 1, negative 1, negative 1. And then y exhibits the same behavior. It goes from 2 to 1 to 0. And then for the last column, x is constantly 1, so we have 1, 1, 1, and y does the same pattern, 2, 1, 0. All right, now let's go ahead and compute our slopes. The first one we have is just add 1 to the y-axis, so that's 2 plus 1 divided by the denominator squared. Negative 2 squared is 4. So dy dx in this point is 3 over 4. So that's what the slope of the tangent line is going to look like. All right, next one. Y plus 1 is 1 plus 1 over the denominator squared, which is 4. 1 plus 1 is 2. 2 over 4 is 1/2. And then the next point, we have 0 plus 1 divided by negative 2 squared again, which is 4. And that gives us 1 over 4. So those are the slope of our tangent lines for the first column of points, where x is negative 2. Now let's advance to the column of points where x is negative 1. So we have y plus 1, 2 plus 1, divided by the denominator is negative 1. When you square that is 1. So 2 plus 1 over 1 is 3 over 1, which is 3. For the next point, y, which is 1 plus 1, over the denominator squared, which is 1. 1 plus 1 is 2. 2 over 1 is 2. The last one is going to be 0 plus 1 over the denominator squared, which is 1. 1 over 1 is 1. All right. Now let's take a look at this one right here. You're going to find out that this output will be exactly the same as this because we're squaring the denominator, which means that the denominator is going to be positive regardless of the sign. All right, so let's go ahead and work it out. Y plus 1, 2 plus 1, divided by the denominator squared, which is 1. Output is 3. That's the slope. Next one is 1 plus 1, divided by the denominator squared, which is 1. So we have 2 over 1, which is 2. And then lastly, 0 plus 1, divided by the denominator squared, which is 1 squared, is 1. All right, so we have all our slopes for the tangent lines. So let's go ahead and graph it. I like to do it column by column, so let's do the -2 columns first. So for the -2 column, it's 3 over 4. So you can think about it, you're going to graph it rise over run. So you're going to rise 3, 1, 2, 3, and run 4. Okay? So it's kind of hard to fit it in here. So one thing you can do is, instead of going to rise over run, you can fall and go back. It's the same thing. Okay? So let's fall 1, 1, 2, put another point 3, and then go back 1, 2, 3, 4. Okay, so this is just an estimate. So think about a line. So what you want, if you want to graph this tangent line, you're just going to put a ruler on these 2 points and just draw a snapshot. Okay, so let me draw the entire line right here. So that's what the line is going to look like. It's a little bit off. Let me fix that. So get down. So the line is going to look like that. But so all I don't need the entire tangent line. I just need a snapshot. Okay. So you see that line, you place your ruler there, and then when you draw your tangent line, it's just a little segment or a snapshot. Okay. So that goes 3 over 4. All right. And then let's shift to this one. It's 1 over 2. So you rise 1 and run 2. 1, 2. Okay. Rise 1, run 2. So we're looking at a line that goes through these 2 points right here. We just need a snapshot of that tangent line. So let's see, a line that goes through those 2 points. Well, I just need a snapshot. So you just draw a small tangent line there. Okay. All right. And then the next one is 1. So you rise 1 and run 1. So we need a line that goes through these 2 points. The slope is positive 1, right? But we just need a snapshot. Okay, make it sure it's good. When you do it with a ruler, it's much easier. This program makes it a little bit, wait a minute. Well, I'm supposed to graph 1 over 4. Let's do that again. So 1 over 4, for that one, we're going to rise 1 and run 4. Okay, so rise 1 and run 4. I started graphing this point for some reason. Anyway, rise 1, run 4. So rise 1, run 1, 2, 3, 4. So it's going to be somewhere here. Let's go ahead and graph the point. So let's see, from that, so from this point right here, somewhere here, all the way through that point. So you place your ruler, and you basically draw the line. So you just need a snapshot. Okay. So there goes the slope of that tangent line. Shift it down a little bit. Okay, now let's go to the -1 column. For the -1 column, we have 3, 2, 1. So let's see, for 3, we're going to rise 3 and run 1. So rise 3 and run 1, I'm going out of the paper. So instead of going up 3 and over 1, I can go down 1, 2, 3, and go back 1. Okay, so our tangent line is going to look something like that. Well, all I need is just a snapshot, right? So make it short. Just preserve the steepness as best as you can, okay? All right. And then the next one is uh, 2. So for 2, we're going to rise 2 and run 1. Okay, so rise 2, run 1. It's too far, so I can basically go down 2, 1, 2, and back up 1. So starting from here, 1, 2, back up 1. So the line that goes through those 2 points gives you the slope of the tangent line. So go down 1, 2, back up 1. So we have this line right here, but all I need is a snapshot. So the line that goes through these 2 points right here. Not as steep as the original one. Let's make it shorter, because all we need is just a snapshot. Okay? Try to preserve the slope as best as you can. And then the next one is 1. So for 1, you're going to rise 1, run 1. So the line, the tangent line, is going to go through these 2 points. Okay, so we just need a snapshot of the slope, the steepness of the tangent line. So let's try to preserve the slope as best as we can. And there you have it. Okay? This is slope of 3, 2, 1. You can see the slope decreasing, right? The steepness of the tangent line is decreasing. Same applies here to 3/4, 1/2, 1/4. So that's the trend here. As you keep getting closer, if you're approaching the the y-axis, you notice that the tangent lines are getting more and more steep. And actually here you have vertical tangent lines, but we're not graphing those because we were asked to exclude x equals 0 from our graphing coordinates, okay? Now let's jump here. All you just have to do is replicate these tangent lines over here. Just copy the steepness. Okay, I'm going to just do that right now. Okay, so I just did a cut and paste, but you know how to do this already. Okay, so there goes the slope of this goes your slope field. Okay, this question hasn't showed up in the past 3 AP exams. I don't know if this is going to show up now, but it's just good to know how to graph your slope fields. All right, let's move on to the B part. For the B part, we have to find the equation of the tangent line to the graph of y equals fx at x equals 1. Okay, so to find the equation of the line, we can use the point slope form of the equation of the line that you learned in algebra. Y minus y1 equals mx minus x1. Okay, and if you get y by itself, you have y equals y1 plus m x minus x1. And the calculus variation of this function known as a linearization, remember the linearization of x is given by f of a plus f prime of a times x minus a. They all mean the same thing, okay? Bottom line, we need x1, y1, and m in order to find the equation of our tangent line, okay? So since it goes through x equals 1, we also have this condition here. You want to keep in mind of f of 1 is equal to 1. So since f of 1 is equal to 2, sorry, that implies that the point 1, comma 2 is on the graph, the graph of y. All right, so keep that in mind. So now that we have a point on the graph, we now know that x1 is equal to the x coordinate of that point, and then y1 is equal to the y coordinate of that point. We have 2 items that we need to create the equation of our tangent line down, the x and the y coordinates. Next thing we need is m. Okay, m is basically the slope of the tangent line at that point, dy dx at 1, 2. So all we just do is evaluate the differential equation at 1, 2, okay? So we know that, let's put this up here. We know that dy dx is equal to y plus 1 over 2, over x squared. Y plus 1 over x squared. Let me make sure that this is right. Yeah, that's right. So all we're just doing is looking for the slope at 1, 2. We just plug in 1 for x and 2 for y. Okay, so that gives us y plus 1, 2 plus 1 over x squared, 1 squared, 2 plus 1 is 3 over 1, which is 3. So there goes the slope. Now we have all the ingredients we need to write down the equation of our tangent line. So we're going to have y is equal to y1, which is 2, plus m, which is 3, x minus x1. X1 is 1. If we simplify that, we're going to have y equals 2 plus 3x minus 3, which implies that y is equal to 3x minus 1. So there goes the equation of our tangent line. It can also be used to do the linearization as we'll be doing in part D. Okay, so that's that. Now let's move on to question letter C.